Bonjour, welcome to Wahsa Distance Education's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. How to participate live? You can call in to the studio at 1-800-465-7144 or 737-4017. Then you can also listen on the radio at 91.9 FM or through the television at Bell Express View channel 972. You can always join through Zoom, where you can ask questions and participate in the content. The Zoom link is available from me, your teacher, or from your DEC. Our class is aired from Monday to Thursday from 11 till 12 in the morning. And we are now in week 2 of our 9-week course. A reminder what work to submit for marking. The support questions are the ones with the pencil icon, and they are not for marking. They are practice problems for you to do. You decide which ones and how many to do. It's best to probably try a couple of each of them and possibly do them all. But if you're understanding a concept and you're feeling really comfortable, feel free to skip questions and spend your time on something that is more challenging. The answers are in the back of the booklets, so check your work to make sure you're on the right track. There have been errors been caught, so if anything isn't making sense to you or you're really unsure, please contact me and let me know, and I can check to see if the mistakes are in the answers. The key questions, the ones marked with a key icon, are the marked questions, the ones you need to submit. So please do all of them, show all of your work, all of your steps, and all of your thinking so that I can give you credit for all of the knowledge that you have and you don't lose marks just because you've made a calculation error. How to submit your work for marking. There's 3 methods. The first is to scan and send your work in electronically. Scan all of your work, and you can do that through your smartphone, either if you have an iPhone. The Notes app has a scan function, and the Android Google Drive app has a scan function. If you need help to do that, let me know and I'll help you. Then you can email it to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca. Or you can also Facebook Messenger it to me at bslatewahsa. The second method is to drop it off into Lookout. We have an outdoor mailbox at 74 Front Street at the side entrance, where that Wahsa building is the big red building next to the post office, and there's a white mailbox next to the white door on the side entrance. The third method is to submit your work through your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax 1-800-463-7852. If you have any questions or concerns, please contact me. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can contact me through Facebook at bslatewahsa. You can call the main office and leave a message for me at 807-737-1488 or toll free at 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m. and I'll get back to you as soon as I can. Connecting through social media is really quite useful if you can. So connecting and friending me on Facebook is a great way to communicate quickly. Also subscribing to my YouTube channel, which is also called Slate Wahsa. Every one of our classes are posted shortly after airing on YouTube, as well as I have videos about common errors or really confusing concepts that might be part of our course or also just might be building concepts. So that's a great place to go if you're having trouble with something. There might be an explanation there for a confusing concept. If there's something specifically you want me to put up there, I'm happy to take requests and make videos about confusing concepts. Math is a very visual subject, so if you can watch either the live Zoom channel or going back and watching the replays at YouTube, I would strongly encourage that. It things will make much more sense if you're able to see what I'm talking about, so just listening to it. All right, today is day 6, and we're in our second week of the course. We are looking at lesson 4 today, which is exponent laws. Our learning goals are such that you can say, I will be comfortable calculating simple powers, and I will understand the logic behind the exponent rules. So knowing you can do that, the success criteria are: 1, I can execute with comfort the multiplication, division, and power of power rules. And 2, I can explain the reasoning behind zero and negative exponents. All right, let's activate our brain and start doing some math. Math minutes are something that many of us experienced in elementary school, where we were drilled to memorize our facts, but they weren't really useful and they didn't teach us any skills or any strategies. So instead of doing things like that, we're going to be activating our brains and developing strategies that we can transfer to other situations. Today's example, we have 3 multiplication questions that are connected on our screen. So we're going to start with 1 times 16. Well, that means that we have 16 groups of 1, or 1 group of 16 things. And so that is equal to 16. Most folks are fairly comfortable with their 1 times tables. Anything times 1 is going to be whatever that thing is. So then our next question is 2 times 8. Well, we can see that 1 is doubled to get 2, and 16 is halved to get 8. So 2 times 8 is still going to be 16, because we have the same amount. We just have taken our total and we split them up. Instead of having 1 group of 16 things, we now have 2 groups of 8 things, but still in total we have 16 things. Then our next expression is 4 times 4. So again, we can see that 2 has doubled to be 4, and 8 has halved to be 4. And so once again, if one of our factors is doubling and our other factor is halving, then our product is going to be the same. It's still going to be 16. So 4 times 4 is equal to 16. This can be really useful for larger examples, for things such that maybe you don't know what something times 50 is, but you know what something times 100 is, and then you can have it. Manipulating numbers like that, such that combination of doubling and halving can be really, really useful in some situations. Okay, mind's on. Let's engage in some prior learning. So we need to remember about exponents. We need to remember what we're talking about when we're talking about exponents before we can apply any rules and laws and understand that. So we have a few parts. We have the base, which is usually the larger number that's written when we have an exponent. And the exponent is the smaller number that is raised up to the right. It's higher and is usually written in a smaller text. The whole thing altogether is called a power. So having a base and an exponent is called a power. Many people interchange the word exponent and power and call the exponent a power. It's not the end of the world if you do that, but I'm going to call, when I'm talking about a power, I'm talking about the whole thing opposed to just the exponent, which is the small part. Okay, so that's the breakdown of what the parts of a power, but what do those things actually mean? So an exponent states how many times the base value is being multiplied by itself. So for example, if we have a base to the exponent 5, that means that we have that base times that base times that base times that base times that base. So we're multiplying the same thing times itself 5 times. Many people make the mistake of multiplying the base by 5. That's not what we're doing. We are multiplying that base over by itself 5 times. It's really important to not make that error. So let's look at some examples. So with numbers, 4 to the exponent 3 is equal to 4 times 4 times 4. 2 to the exponent 8 is equal to 2 times 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 2. Sometimes you need to count on your fingers because you have so many to keep track, and that's totally fine. -7 to the exponent 4 is equal to -7 times -7 times -7 times -7. The base is negative, and so we are multiplying that multiple times. All right, so with variables, what that looks like, x to the 5th is equal to x times x times x times x times x. Now, on the screen, I have written x's and then multiplication signs that are x's, and that can look really, really confusing. So instead, what we do if we are expanding out variables, and if we're using x, but generally if we're using any, so that we're not confusing whether or not we have x's or time signs, we use a dot as multiplication as a way to signify that we are multiplying. So x times x times x times x times x with dots in between is multiplying all of those x's together. So a squared is equal to a times a, and t to the 10th is equal to 10 times 10, sorry, not 10. See, this is the mistake. It's so easy to make it. T times 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 t. So having so many variables makes it really easy to make glitches and make mistakes. And so we're going to be looking at rules about how to simplify our exponents so that we don't have to keep track of how many bases we're multiplying in the same way, that we don't have to expand them out so much and then possibly lose information. So on your calculator, you probably are familiar with the squared button, which is usually something like x to the exponent 2. So you have an exponent of 2, which is that small raised 2. That's probably fairly familiar to you. But your calculator also should have buttons that could have any exponent, so that it's not just squared, where you could put in 3 or 8 or 10 or 100, any exponent, any value for the exponent. And that could look like x to the exponent y, or it could look like y to the exponent x, or it could look like a to the exponent b, or it could even look like a small triangle. I don't actually know what this key looks like, or what it's called, but it's sort of the tip of a triangle is one way you could look at it. And on my keyboard, it is when you press Shift and 6. That's the computer version of that symbol. So that might be on your calculator as well. There might be something else that's on your calculator that could be a variation of one of these, but those are generally the buttons that I've noticed. If you can't find yours on your calculator, let me know, and maybe take a picture of your calculator and send it to me, and I can look for it and see if I can figure it out. Each calculator is different, and how you use these buttons are different, so you kind of need to experiment to figure out how to use your buttons, which order you press things in. Generally, you press the base and then the button and then the exponent, but you need to figure that out. You need to practice a little bit. So doing something like even doing squared, you can put like 3 squared using one of these any exponent buttons to see if that is going to give you 9, what you expect. So you need to play around with that a little bit. This is also why it's really important to practice with the calculator that you're going to be using for your assignments and for your exam, because you're going to get comfortable with that, with those buttons. And if you are using, say you're using a smartphone, which maybe is all you have right now, and then you that for your exam, then the buttons might be different on your calculator, and then that might really mess with you. So practicing with the calculator you're going to use is really important to become familiar with your buttons. If you don't have a calculator, a scientific calculator, you need one, let us know and we can send you one. Okay, so let's activate some new learning. As always, when will you use this in real life? Wondering, of course. We're developing in this course the skills to attack problems your life, you're definitely going to have situations where things come up and you're going to need the skills to figure out what information you have, what information you don't have, what information you need, and having the stamina and the confidence to be able to attack those problems and work through them. So we're developing those skills in this course. All right, multiplying powers. That's the first rule that we're going to be looking at. And this is on page 26 of your IL book. We are going to go in the order that the IL book it does. So the question is, how do we multiply powers with the same base? What does that mean? So looking at an example, we have 2 to the exponent 4 times 2 to the exponent 3. We're going to expand that out to see what actually that means. So 2 to the exponent 4 is 2 times 2 times 2 times 2. And then we're multiplying that by 2 to the exponent 3, which is 2 times 2 times 2. So really, we just have 2 times 2 times 2 times 2 times 2 times 2 times 2. We're multiplying the base of 2 7 times. So we can simplify that to be 2 to the exponent 7. So a shortcut, instead of having to expand every single time and then simplify your base and your exponents, 2 to the exponent 4 times 2 to the exponent 3 is equal to 2 to the exponent 4 plus 3. So our exponents we're going to be adding together, which is equal to 2 to the exponent 7. So every single time you can see that if you're multiplying your bases and you have the same base, that really you're just multiplying the total number of that base together. And so that's why you can add your exponents, because you have that many of the bases. So for example, with variables, x squared times x to the 6th is x times 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 x. Again, that is total. We just have x times 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 x, which is 8 x's. So that it just equals 8. X to the 8th. I made an error on my screen. I forgot to change something. So this should be x to the 8th, not base 2 to the 8th. We keep our base the same. My bad. So a shortcut would be to x squared times x to the 5th, x to the 6th is x to the 2 plus 6, which equals x to the 8th. So our multiplying power rules is when multiplying powers with the same base, we add the exponents. So every time that you have 2 or 3 or more powers where you have the same base and you're multiplying, you can always add the exponents. Okay, so I keep saying that the base must be the same. So let's look into why that needs to happen before we move on further. So looking at the example, 1 to the exponent 3 times 9 to the exponent 2. So we don't have the same base. We have a base of 1 and we have a base of 9. So let's expand that. So we have 1 times 1 times 1 times 9 times 9. Okay, so in total, we have 5 terms. We have 1 times 1 times 1 times 9 times 9, but we don't have the same base. We can't say that that's all 1 to the exponent 5 or 9 to the exponent 5 because we don't have 1 5 times. We don't have 9 5 times. So that doesn't work. We can't combine those exponents. It just doesn't make any sense. So we can't do 3 plus 2. Similarly, if we have variables instead of numbers, we have x to the 4th times y to the 7th. So we have x times x times x times x times y times y times y times y times y times y times y. We have 11 terms, but we don't have 11 of one thing. So we can't combine those and say that we have one thing. So we can't add 4 plus 7 to say that we have x to the 11 or y to the 11 because we don't have 11 x's times each other or 11 y's times each other. Most people don't make this mistake with their numbers, but might make this mistake with variables. So it's really important to remember that your base must be the same. You can't add your exponents if your base is not the same because it doesn't make any sense. We all of a sudden are losing information because we don't have 11 of one thing or of the other. Okay, so now let's look at what the dividing powers rule is. So again, this is on page 26 in your IL book. So how do we divide powers with the same base? So for example, with numbers, 8 to the 6th divided by 8 to the 3rd is equal to 8 times 8 times 8 times 8 times 8 times 8 divided by 8 times 8 times 8. So we need to remember that with our exponents, we're still multiplying all of our bases. Even though we're dividing between the two, we're still multiplying all of our bases for the exponent. So we can rewrite that such that we have our 8 times 8 times 8 times 8 times 8 times 8 over 8 times 8 times 8, writing our division either with the division symbol or sort of like a fraction model is the same thing. They're just different ways. I generally write my division looking like more like a fraction in terms of having my numerator as what I am dividing by my denominator, which is what the number of parts that I'm dividing it into. So this is how you're going to see me generally write my division opposed to using the division symbol. Okay, but it's the same thing. So now, in terms of simplifying what that means, well, if we have 8 divided by 8, well, that's just 1 that cancels each other off, right? So then if we think about how multiplication and division are commutative, they are sort of the same thing but opposite. So we can do them in either order. So we can just cancel off our number of 8s that we have that cancel. So we can, and every time we do that, they're equal to 1, because if I times something by 8 and then I divide it by 8, I'm not actually changing it. So those 3 8s from the denominator and 3 8s in the numerator cancel out. So then we end up just having 8 times 8 times 8 all over 1, which is just 8 to the exponent 3. So then as a shortcut, we can think of, because that's a lot of steps to try to track. So the shortcut is our goal. It's what is our rule that we can do it. So 8 to the 6th divided by 8 to the 3rd is equal to 8 to the 6 minus 3, which is equal to 8 to the 3rd. So we can see that because what we have on the top and on the bottom cancel off, we're actually subtracting what we have on the bottom from what we have on the top. So let's look at an example with variables. So b to the 9th divided by b to the 7th is equal to b times 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 b divided by b times b times b times b times b times b times b. We can understand why we don't want to have to expand this every single time to figure this out, right? So again, we're multiplying things by b and then dividing them by b. So that really just means that they can cancel off, that they're really just multiplying and dividing by 1. They don't actually change our information. So we end up with b times b over 1, which is equal to b squared. So our shortcut, b to the 9th divided by b to the 7th is equal to b to the 9 take away 7, which is equal to b squared. So our division rule, or dividing powers rule, is when dividing powers with the same base, subtract the exponents. All right, power to a power rule. We're going to go through rules and then we're going to do some practice afterwards. If you want to stop and pause and do practice in between, that's totally fine. So how do we raise a power to a power? What does that mean? So if we have a base and are raising it to a power of 5, that means the base times base times base times base times base 5 times, right? Okay. But if instead of that base just being one number or one letter, if that is something with an exponent, for example, 4 squared, that means that really we're doing 4 squared times 4 squared times 4 squared times 4 squared times 4 squared. because we had that base times itself 5 times. But 4 squared is 4 times 4, right? So that means that every time we have 4 squared, really we have 4 times 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 4. Again, you can see why having shorter rules is going to make our life easier opposed to having to track how many of each of those terms we have. So in general, we just have 4 times itself 10 times is what we end up having if once we simplify, once we look at what we actually is going on. So again, I forgot to change, sorry, my bases, my bad, on the screen. So we have 4 to the exponent 10. That's what I get for copying and pasting in my PowerPoint. So because we have our base 4 and we have 10 of them, so that we have 4 to the exponent 10. Okay, so looking at the shortcut of that, so 4 to the exponent 2, all of that to the exponent 5 is equal to 4 to the exponent 2 times 5. We end up multiplying our exponents together. So we end up with 4 to the exponent 10. So let's look at an example with variables. So we have y to the exponent 9, all to the exponent 4. So that equals, you know, that we're having everything to the exponent 4. So our base is all to the exponent 4. So we have y to the exponent 9 times y to the exponent 9 times y to the exponent 9 times y to the exponent 9. And we expand that, and we have y times y times y times y times y times y times y. I think I did that right. And we repeat that 4 times. It's a lot of y's to say it all out, and I'm going to get lost. So we can see that really we're just doing that 36 times. We're doing y to the exponent 36 is the same as 4 groups of y to the exponent 9. So for our shortcut, that is y to the exponent 9 all to the exponent 4 is equal to y to the exponent 9 times 4, which is equal to y to the exponent 36. But you can see these rules can be really helpful to make your life easier. So the power to a power rule is such that when power to a power, we multiply the exponents. Okay, so let's look, we're going to look at a complicated example of this power to a power because this can happen fairly frequently where we have a lot going on that we're raising all to another power. So for example, we have -6, x to the 4th, y to the squared, z, and all of that is to the exponent 3. So what does that mean? So we have our 3 groups of our base, right? We're doing this 3 times. And our base is such that we have -6, x to the 4th, y squared, z times -6, x to the 4th, y squared, z times -6, x to the 4th, y squared, z. Okay. So then we can rearrange that because we're just multiplying throughout, and we can clump our like terms together, and we see that we have -6 to the 1, right? Because -6 with no exponent is the same as saying we have 1 of that. So -6 times -6 times -6 times x to the 4th times x to the 4th times x to the 4th times y to the squared, y squared times y squared times z to the 1, z to the 1, z to the 1. If we don't have an exponent on our number of variable, that means that we have an invisible 1 because we just have one group of that. And so we're not, so we don't write the 1, but that's what's going on. And that's important to remember. So we can simplify that by saying, okay, we have -6 to the exponent 1 times 3 times x to the exponent 4 times 3 times y to the exponent 2 times 3 times z to the exponent 1 times 3, which simplifies to be -6 cubed x to the 12th y to the 6th, z to the 3rd, or z cubed. So when you're raising a power to a power, you need to raise, if you have multiple numbers or variables that you're raising all to the power at the same time, you need to apply that third, that power on the outside, to each of your numbers and variables on the inside. So it's really important to remember. And often people might do part of it, but not all of it. People might do fairly common people will do the variables, will remember to apply the exponent to the variables, but forget to apply it to the number, to the coefficient as well. You need to do it through for all of the numbers and variables. So then you can, to simplify that, you then calculate what you can calculate. So negative 6 to the 3rd is equal to negative 216. And so then your final answer is negative 216 x to the 12th, y to the 6th, and z cubed. Okay. Zero exponents. Again, this is a lot of information. Pause if you need to, and come back to it to the next part. We're going to do some practice questions in a minute. Zero exponents is on page 27 of your IL book. So what does a zero exponent mean? What's going on? So we're going to look at the example 7 squared divided by 7 squared. Okay, so 7 squared is equal to 7 times 7. And we're doing 7 squared divided by 7 squared. We have 7 times 7 divided by 7 times 7. So those cancel off completely, and we end up having 1, right? We have the exact same thing on that we're dividing by. That means that we have equal to 1. Okay, but then we looked at our shortcut. If we remember our shortcut rule for division, 7 squared divided by 7 squared is equal to 7 to the exponent 2 take away 2, which is equal to 7 to the exponent 0. So 7 to the exponent 0 is equal to 1, because we know that 7 squared divided by 7 squared is equal to 1. So we have the same thing in the numerator as the denominator. So that's always going to equal 1. But we know that following our division rule, that means that our exponent we subtract, and we end up having 0 as our exponent. Okay, so let's look at an example with variables to see if that holds true, if that continues to be the same. So t to the 8th divided by t to the 8th means that we have t times 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 t divided by t times 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 t. So those t's we can cancel off to see what happens, and we can see that they cancel off exactly evenly, and we end up with 1 divided by 1, which is equal to 1. So our shortcut, t to the 8th divided by t to the 8th is equal to t to the 8 take away 8, which is equal to t to the 0. So t to the 0 is going to equal 1. It doesn't matter what our base is. Anything to the exponent 0 is always going to equal 1. So our rule is anything with an exponent of 0 equals 1. There's a little bit of a caveat, except 0 to the exponent 0 cannot be solved, because we can't divide by 0, and our whole reasoning for this is based on having the same base as the top to the bottom, right? So if we can't have 0 divided by 0, that doesn't make any sense. So 0 to the exponent 0 cannot be solved, but anything else to the exponent 0 equals 1. Okay, our last rule, negative exponents. Again, this is on page 27 of your IL book. And what does having a negative exponent mean? So we're going to look at another example to figure this out. We have w to the 4th divided by w to the 6th. So this equals to w times w times w times w divided by w times w times w times w times w times w. Okay. So we continue to cancel off as we can, right? Because if we're multiplying something by w and dividing by w, that's just like multiplying by 1, doesn't make any difference. So we end up with 1 over w times w once we cancel out all the w's that we can cancel out. So that equals 1 over w squared, right? Because we have 1 over w times w, that's 1 over w squared. Okay, so then looking at our shortcut method, w to the 4th divided by w to the 6th we're dividing, that means we subtract our exponents. So w to the 4 take away 6 is equal to w to the negative 2. So w to the negative 2 is equal to 1 over w to the 2. So our negative exponent rule is a negative exponent equals the reciprocal of the base. So in other words, 1 over the base. So if you have x to the negative 5, then that is equal to 1 over x to the 5th. Let's look at some more examples because there's some more tricky examples. So what happens if we have 1 over a base to a negative exponent? So we have 1 over 2 to the exponent negative 10. So having a negative exponent means that we flip what we have. So what that looks like is that is equal to 2 to the exponent 10 over 1. We have a fraction, so we flip it, and we then lose our negative exponent. So that really just equals 2 to the exponent 10. Another tricky example is if we have a fraction to the exponent of a negative number. So we have 7 over 8 to the exponent negative 4. So what that equals is that we flip our fraction and we have 8 over 7 to the exponent 4, which is equal to 8 to the exponent 4 over 7 to the exponent 4. Okay, so we've done lots. All of that is connected to the support questions on page 28, questions 1 and 2. So if you haven't paused yet, now's the time to pause and do some of those support questions and see how you're doing and see if you can remember those rules. Let's consolidate all that we've learned. That's a lot of information. We're going to do a quick recap and then let's do some practice. So the exponent laws highlights of lesson 4. This applies for things that have the same base. That's really important to remember. So the multiplying rule, powers rule, means that you add the exponents. So x to the a times x to the b is equal to x to the a plus b. The dividing powers rule is you subtract the exponent. B to the x divided by b to the y is equal to b to the x minus y. Power over power rule, you multiply the exponents. T to the n all to the p is equal to t to the n times p. Those are the general ways of explaining this. So if you can comfortably execute these calculations, the multiplication, division, and power rules, then you have managed to complete success criteria 1. And so then 0 exponent rule, anything with an exponent of 0 equals 1. And the negative exponent rule is a negative exponent equals the reciprocal of the base. Example 1 over the base. So a to the negative b is equal to 1 over a to the b. And if you have a fraction, x over y all to the negative z is equal to y over x to the exponent z. So our success criteria 2 was, I can explain the reasoning behind 0 and negative exponents. So if you're comfortable with that, you managed to meet success criteria 2. Okay, so then let's get into some practice, but first we need to make sure that we know what the question's asking. So generally these questions come up in 2 forms. We have evaluate, which means calculate the final answer, and you should have a number. If it says evaluate, we're looking for a number answer. If it says simplify, we're combining the exponents as much as possible, and we should have no negative exponents. You should always just have positive exponents. That's what our goal is. Okay, so let's do some practice questions. Let's evaluate the following. So 6 to the exponent 4, just to make sure that we know how to use our calculator buttons, I'm going to show what that looks like on a Desmos calculator, which I'll put in the show notes so you can have that on my calculator. So we had 6 to the exponent 4. So that's how I calculated in my calculator, and I get is equal to 1,296. So if I'm evaluating, 6 to the exponent 4 is 1,296. And that's all we do. Okay, if I have -5 to the exponent 3. I can do that in calculator, or this one I actually know in my head. So -5 times -5 times -5 I can think of. Well, -5 times -5 is positive 25, and positive 25 times -5 is -125. So sometimes you can just do them in head, you get familiar with them. Other times you use your calculator. Either is fine. 7 divided by 9 squared to the -2. Well, this I'm going to, before I evaluate it, I'm going to simplify it a little bit because it's a little bit confusing. So I have 7 times, sorry, that's confusing why I said that. I'm thinking the best way. So you can put this just straight into your calculator. And why don't we do that to just see what your calculator gets. So if we do 7 divided by 9 to the exponent -2, that gives us an answer of 567, which is kind of surprising because I would think that it's going to be a decimal because we have division, right? But if we think about this, because we have a negative exponent, what this really ends up looking like is 7 times 9 squared, because we flip what we have on the bottom, and because we're flipping it, that means that we end up multiplying it on the top. And so that is equal to 7 times 81, which is equal to 567. So it can be a little confusing. You need to make sure that you're paying close attention. Okay, so then question 4, we have 2/3 all to the exponent -1. And so that we have a -1 exponent. So we know that we're going to flip our fraction. So we have 3/2, all of that to the exponent 1. Well, that to the exponent 1 is just 3/2. So then we're done. We've got an answer. All right, simplify the following. Question 4. 4 to the 12th times 4 to the -3 divided by 4 to the -9. So this definitely looks confusing. So we're simplifying it, but we know that we have the same base. That means that we can use our rules, right? So we have 4 to the 12, and then because we are multiplying, we're going to add 12 plus -3. And then because we're dividing, we're going to subtract -9. As you can see, knowing your rules, your integer rules is really important. So this is the same as 4 to the 12th. If we are adding -3, we're really just subtracting 3. And if we're subtracting -9, we're really just adding 9. So we have 4 to the exponent 12, take away 3 plus 9, which is equal to 4. 12 take away 3 is 9. 9 plus 9 is 18. And then because we're simplifying, that's as far as we're going to go. We don't need to calculate what that actually equals. Okay, next example. We have 9 to the exponent 9 divided by 9 to the exponent 4, all divided by 9 to the exponent -2 divided by 9 to the exponent 0 times 1/9 to the exponent -3, all to the exponent 6. There's a lot going on. Sometimes you're going to need to do this in steps in order to simplify your life. So, and that's fine. You decide what makes sense in terms of how you can simplify it instead of doing it all in one step. So let's do it in parts. Let's simplify because we have each of these division ones. Let's simplify those inside the brackets first, and then we can simplify that's in total. So luckily generally we have the same base. We're going to have to be careful with this one over here, paying attention to that. So 9 the exponent 9 take away 4, because we're doing 9 to the exponent 9 divided by 9 to the exponent 4 is our first part. Okay, so then divide, we're going to leave that division there. We're going to think about what happens with our second one. Okay, well, 9 to the exponent 0 is just 1, so that doesn't actually change this. So that just leaves that this is 9 to the exponent -2, because our 9 to the exponent is equal to 1. And then we're going to times, and then 1 over 9 to the exponent -3. Well, 1 over something with a negative exponent is really just that base to that positive exponent, because we just flip that, and then all that to the exponent 6. Okay, so then we have 9 to the exponent 5, because 9 to the exponent 9 minus 4 is 9 to the exponent 5, divided by 9 to the exponent -2, because that we can't simplify that one further, times, and then 9 to the exponent 3 to the all to the exponent 6 is going to be 9 to the exponent 3 times 6. So then we have 9 to the exponent 5 divided by 9 to the exponent -2. So that means if we're dividing, we're subtracting our exponents. 5 take away -2. And then times 9 to the exponent 3 times 6 is 18. So then we have 9 times, or to the exponent 5 take away -2 is actually 5 plus 2. So 9 to the exponent 7 times 9 to the exponent 18. Okay, so then because we are multiplying our two bases are the same, so we have 9 to the exponent 7 plus 18, because we can just add our exponents. And then we have 9, 7 plus 18 is 25. And there we go. We've simplified as much as we can. Whew. It's going to be tricky to keep track of them, so it's really important to be paying attention. And then we have another example, which has even more going on. So here we have 8x to the 7th, y to the -3, z to the 2 times 3, x to the -2, y to the 5th, z, all divided by -6, x, y to the 5th, z to the -2. So when you have something like this where you have so much going on, what you can do is group together what your numbers and your variables that are the same. So we have our numbers, we're going to have 8 times 3, right? Because we're moving around we're collecting our terms that are like, and then we're going to have x, and we're multiplying, right? Brackets mean multiply. So we have x to the 7th times x to the -2. So that means we're multiplying, we can add our exponents. So we have 7 plus -2. And then we have y, -3 is our exponent, times y to the 5th. So we have -3 plus 5. And then we have z. Our exponents are 2 plus 1. So that is what we're multiplying on the top. And then we're going to leave what we have on the bottom alone for right now. So we have -6, x, y to the 5th, z to the -2. Okay, then let's simplify that. So we have 8 times 3 is 24. X to the exponent 7 plus -2 is going to be x to the exponent 5. Y to the exponent -3 plus 5 is going to be y to the exponent 2. And z to the exponent 2 plus 1 is z to the exponent 3. And that's all divided by -6, x, y to the 5th, z to the -2. So 24 divided by -6 is going to be -4. So we can simplify that. And then we have x, 5, x to the 5th divided by x. So we have x, 5 take away 1, and y squared divided by y to the 5th. So we have y2 take away 5, and we have z to the third divided by z to the negative 2. So we have z to the 3 take away negative 2, which is all going to equal negative 4 x to the fourth, y to the negative 3, and z to the fifth. Now we've run out of space, so I'm just going to draw an arrow to up here because we have a negative exponent and we don't want to have a negative exponent. So that is equal to negative 4, x has a positive exponent, so 4, and z has a positive exponent, so z to the fifth, but that's all going to be divided by y to the third. It's a little bit confusing. Do some practice and let me know if you have any questions. Okay, so one last thing where we express as a single power. So if we have variables as our examples, we have, so here we have 5a divided by 5b times 5 to the a. So we have 5a minus b plus a. So we can say that that's 5 2a minus b. We have 3 to the negative a times 3b over 3a all to the c. So 3 to the negative a times, if we have doing power of the power, so we multiply our exponents together. So we have 3 to the bc divided by 3 to the ac, and that is equal to 3 to, so now we're just multiplying and dividing. We can combine our terms into our exponents. So we have 3 to the negative a plus bc minus ac. It can look messy, but this is just sort of what how you can play and get comfortable with the numbers. And then finally we have 11 to the 2b minus a divided by 11b over 11c plus b. Can get really messy, but just the same thing. You have the same base. We have 2b minus a minus, and then we're dividing, so we're subtracting our exponents. So b take away c plus b. So that is equal to 11 2b minus a minus b plus c minus b. You have to pay attention to what your signs are in order to make sure you get your signs followed through properly. 11 2b minus b minus a plus c is equal to 11. Our b's all cancel off, so we have negative a plus c. It can get a little bit confusing. You got to follow along slowly. Unfortunately, we don't have tons of time. We're running out of time. So those are what you can do with those, with your exponent laws. So remember, practicing them over and over again is really important so that you get really comfortable with them. Do the support questions. You can find other questions online if you need more practice. If you want to let me know if you need more practice, I'm happy to provide some. If you're confused about any of the parts, let me know. They can get, it's easy to mix them up and confused. So let me know if you have questions and we can work through them together. As always, contact me. You can leave a message and I can call you back at 807-737-1488 or toll free 1-800-667-3703. Emailing me at bronwyn.slate, spelled BRONWYN.SLATE at nnec.on.ca, or Facebook messaging me at bslatewahsa, and then connecting to the replay so you can watch things slower or pause and take breaks if you need to at bslatewahsa as well. It was great to have you today. Thanks for coming, and I hope to see you next time. Bye-bye.